Hello, in this video we're going to derive a Cobb-Douglas cost function. Here is our Cobb-Douglas function. It is a function of units of labor and units of capital. Cost minimization requires that the marginal product of labor divided by the marginal product of capital equal the price of labor, the wage, divided by the price of capital, R. We're going to get the marginal product of labor and marginal product of capital, taking the partial derivative of the production function with respect to labor. The exponent on labor, this 1/2, comes down in front, so 4 times 1/2 leaves us this 2. We're going to subtract 1 from this exponent on labor, leaving us with 1/2 minus 1, or L raised to the minus 1/2 power, and we don't do anything with the K term. And as for the marginal product of capital, take the partial derivative of the production function with respect to K. This time we take the exponent on the K term, bring that down in front, so 1/2 times 4 leaves us with 2. And then we subtract 1 from that K exponent, and we have the following result. Putting the marginal product of labor over the marginal product of capital and setting that equal to the ratio of the input prices. And now simplifying. The 2's cancel. And this L to the minus 1/2, we're going to move that into the denominator. And this K to the minus 1/2 in the denominator can be moved up into the numerator. And then we add the exponents on the K terms and the exponents on the L terms. And we have the following result. Our next step is to divide the production function through by K. We're going to divide the left-hand side and the right-hand side of this equation right here through by K. So the left-hand side becomes Q divided by K, and the right-hand side becomes the following. Simplifying up the right-hand side a little bit, this K to the 1/2 divided by K just leaves us with K to the 1/2 in the denominator, so we can write that result like this. The next thing is to recognize, since K divided by L equals a wage divided by the price of capital, it means that L divided by K equals the price of capital divided by the wage. So we're going to make a substitution. This L divided by K, we're going to replace with R divided by W. Making that substitution. Moving on. Now we're going to solve this expression for K. So multiplying everything through by K, multiplying both sides through by K, and simplifying some, we get this result right here. And let's get the capital cost. So the capital cost is going to be the price of capital times units of capital. So we're going to take this expression right here and multiply it through by R. So we have R divided by R to the 1/2 power, which will just leave us with the following result. So that is our capital cost. Now let's get our labor cost. Here's our production function once again. This time we're going to divide through it by L. So dividing both sides through by L. Recognizing we saw this result earlier, K divided by L equals the wage divided by the price of capital, I'm going to make a substitution. After making that substitution, we have this result. And we're going to be solving this result for L. So that's our last step. And now solving for L. I'm going to divide through by 4, and then I'm going to multiply through by this reciprocal here. Leaves us with this result. And to get the labor cost, it's going to be units of labor, L times W. So we take this result over here on the right-hand side and multiply it by W. So we got W being divided by W to the 1/2 power, and that will just become W to the 1/2 power in the numerator. So our total labor cost, now putting everything together, total cost is labor cost plus the capital cost. Plugging in our expression for the labor cost and the capital cost we found earlier. And now simplifying, we have our Cobb-Douglas cost function, total cost function. Okay, that's it.